In this short video, I'm going to demonstrate the three types of basic batters available in advanced road design. The first type of batter I'm going to show is the standard slope batter. The user can specify a slope that is applied in a cut and fill situation. The width of the batter from the road will vary. However, users can also assign an alignment which is used to control the maximum offset of the batter. This is used to contain the batter within a road reserve. In the cross-section template editor, users can define the initial batters for a road. They can do that by selecting the left side and right side buttons. If no batters are to be assigned, then the user selects no batters. You can specify what the slope batter will be in a cut and a fill situation, and you can also define a fixed width batter if you like, and you specify a width from the center line. In this drawing, I've already created a road and I've applied slope batters at a 1 in 4 slope. The first thing I'm going to show you how to do is override those batters over a certain chainage range. You can achieve this by opening up the design data form and selecting the road. And listed on the left hand side here is the option to override the batters. I'm going to add a new entry in here. And for this first example, I'm going to override the slope batters. This is really easy to do. The first thing I do is define the chainage range that I want this override to occur. In this example, I'm going to do this for the first 50 meters. I then specify the side that I want to override. Do I want to override the left batters or the right side batters? In this case, I'm going to override both. The next thing you need to do is tell the software what the shape of the batter will be at the start chainage and what the shape of the batter will be at the end chainage. You do have the option to set the shape for the start and shape for the end, and that way you could merge the batter from one chainage to the other. So you might, over a certain chainage range, want to override the batter from a 1 in 4 slope perhaps to a 1 in 6 slope. If the slope is going to be constant over that chainage range, then you tick on constant slopes, and then you only need to define the slope at the start chainage. So for the left hand side, I'm going to change my batter to be 1 in 6, and on the right hand side I'm going to change it to be a 1 in 8 slope. If I select add update to that, you will see in cross section that the batters have updated, and also in plan view the line work representing the batters has updated for me. As I continue to make changes to the batters and select add update, you'll just see the line work and cross section update instantly. Next thing I'm going to show you how to do is use an alignment to control the maximum offset of the batter. So if the batter is going to extend past the alignment, the software will trim the batter back to that alignment. I've created an alignment in this drawing and I've named it max right alignment. In my cross section you can see the blue line on the right hand side indicating the position of the alignment. My right side batter is currently at a slope in 1 in 10. To set this up so that the batter doesn't extend past that alignment, all I need to do is set the right maximum offset alignment option to max right alignment and select add update. And you can see there now that the batter no longer extends beyond that alignment. If for whatever reason 1 in 10 falls within that alignment, then the software will adopt that, but at any time it extends beyond the alignment, the batter is brought back to the aligned position and the result is a varying or steeper batter. The second type of batter I want to show is a fixed width batter. This batter is created at a fixed width from the road, which results in a varying crossfall. This type of batter can be defined in the template editor or applied as an override in the design data form. I'm going to show you how to override the batter to be a fixed width batter over a certain chainage range, and I'm going to apply that from the design data form. So what I do is I select on batters once again and add a new entry, but this time I'm going to specify fixed width from centerline batters. I specify the chainage range. I'm going to do this for the first 50 meters, and then I set the width on the left and the width on the right. Now it is important that the width that you set is contained within the section width you initially specified for the road. So if I just quickly go to resample cross sections and select on set section widths, my batters can't be more than this width. If they are, then I need to increase the width for my road. Once again, I've got the opportunity to merge the batter from the start chainage to the end chainage. For whatever reason, I could add a merge region coming out from, say, 8 meters, but ending up at a 12 meter width. In this case, I'm just going to select on constant width. So when I apply that override, you can see now that the batters extend to a 10 meter offset for the first 50 meters, and I can see that represented in plan view as well. And then after that chainage range, it goes back to the 1 in 4 slope batter. The final type of batter I wanted to show you is the dual leg batter. This type of batter was created for a council in Victoria. The first leg is created at a fixed width from the road centre line. If the slope is outside the slope range specified, then the maximum slope is applied and a second leg is formed at a specified slope to the surface. If the slope of the first leg falls within the slope range and intercepts the surface, then the first leg is created at this slope and the second leg won't be added. Okay, so I'm going to show you how to add a dual leg batter override. So once again, I select batters from the list and add a new entry. This time I specify dual section batters. Click OK. I'm going to apply this over the entire length of the road. The first thing I do is I set the width for the first leg. I want to set this at 8 meters. I then specify the slope range. So as mentioned, if the slope to this width to the surface is outside the range that I specify, then the maximum slope is used and the second leg is formed. I'm going to set this slope range at -8 for the minimum and 4 for the maximum. If a second leg has to be formed, then I want that forming at a 1 in 1 slope to the surface. So if I select on Add Update, you can see at this particular cross section that both legs have formed, and that is because the slope of the first leg to the 8 meter width is outside that slope range, and so the second leg is formed there. What I'm going to do is open up the vertical grading editor, and I'm going to change the levels at that particular cross section. And if we can fix up the slope of the first leg, maybe lower the levels, we'll see that only the one leg will form to that 8 meter width. So let's lower the levels of the road. Okay, and then you can see that that second leg is no longer being formed and the slope is changing. If we increase the levels, you can see the second leg forming, but the closer we are to the surface there, you can see we no longer need that second leg because the first leg falls within that slope range at the 8 meter width. So thank you for watching this video on some of the standard batters inside Advanced Road Design.